Okay, so I welcome you all in this class. Good evening to all of you. How are you? I hope you are doing good. So बहुत ज़्यादा ठंड हो रही है इसलिए ये आउटफिट है तो डो नॉट वरी अबाउट इट. We will wait for 1 or 2 minutes more. Let the others to be join. Okay. Till now you can, till then, you can discuss any kind of issue you are facing with the class, like joining in the class, the link of the class, timings of the classes. So if anyone facing any kind of trouble, they can write it in the chat box. Okay. Or if they are not facing, they can give me a thumbs up. Okay. Hello students, how are you? Okay. So in the previous class, what we have covered, we have seen the basic terminologies of thermodynamics, and what is the thermodynamics, we have deal with it. Okay, so I will take 5 minutes to explain this, whatever we have did in the previous class. Okay, so we have studied what is thermodynamics, the basic terminologies that we need to explain the thermodynamics. Okay, so thermodynamics is made up of thermo and dynamics. Okay, so thermo means basically heat, and dynamics is the force applied by heat. Force applied, because when we in mechanics also there are two branches, kinematics and dynamics. Kinematics mean we deal with the motion, and in dynamics we deal with the cause of motion. So here the cause is heat, and the effect of that cause is this dynamics. So we are going to learn this plus thermo plus dynamics, which means the cause of the force exerted in a system by heat is combinedly called as thermodynamics. Okay. In this we have seen that what is a state, okay, what is path, what is process, how many types of process we have. We have two types of process, reversible and irreversible, cyclic also. Okay, and properties, thermodynamic properties, yeah, you can say thermal properties. In thermal properties there are two types of property. What? And intensive and extensive. Intensive, which is independent of quantity. Independent of quantity. And extensive means which depends on the quantity. Depends on the quantity. Hello Virendra, you are from JNV Ballerina. Good evening. So we are just revising what we have did in the previous class. Okay. State is the measurement of thermal property at equilibrium. And this is nothing but the pressure, temperature, and volume. It tells us about what is the pressure, what is the temperature of the system, and what is the volume. And the most basic and the very initials we have learned about the system and its type. It has three types of system we have: open, closed, and isolated. Plus surrounding we have, and this combined termed as universe. Okay. So state is tells us about the position of any system. In thermodynamics, what does the position mean? About the, we are giving information about the thermal properties of that system. That how we characterizing it. What is the temperature of it? What is the volume of it? What is the pressure of the system? So state tells us about this. Okay. State is the condition of thermal properties. In which conditions are thermal properties is. Okay. Path. Path is nothing but which connect the state 1 to state 2 or one state with another state. That is called as path. And whatever the process we have take to cover this path from state 1 to state 2 is called the process. Okay. Like we have Himalaya and we have Kailash. So these are the two peaks we have. Okay. My voice is not clear. Just a second, I'll check. Is it not clear or is it not, is it low? Now it is clear to you? Now it's okay. Just a second. I think now it's clear to you, clear and loud. Got it? Is it clear now? Welcome, bache, welcome. And please let me know if you are facing these types of problem, na? So what I'm talking about the state, path, and process. So let's say we have two states. One is Himalaya, one is Kailash. We want to reach the Kailash. We have a path. Now, the way which connect this state to this state, Himalaya to Kailash, is called as path. And the way that we cover this path, we are covering this path by foot, or we are taking an aeroplane, airway, we are taking the roadway. So that is the process. How we are completing this path, how we are reaching from state 1 to state 2. Okay. This is it that we have did in previous class. Now, so today the first topic that we are going to learn is state function. So it is very simple. Do not hesitate. Do not confuse with the name. What is the function and what is all. So state function is nothing but the thermodynamic properties which depends on the state of any system. Which means they are not interested in the path that we have taken. the process that we have did. Okay, they only depends what is the final state and what is the initial state. Same as of mechanical energy में potential energy. Potential energy will not depends on that how you lift that particular object to height h. It will only depend that where it is initially and where it is finally. Okay, so that is that type of property makes any function or makes any property to a state function. Got it? In the definition also you can see. So those function or those variable, yeah, those thermodynamic property which depends only upon the end state of a system, okay, is known as the state function. Example for that is energy. So energy will only depends on the state of that thermodynamic system. Okay, it is not depends on that how we have achieved that state, which means it is independent of the path that we have taken to reach at that state. Got it? It's a very important thing to note. So this is state 1, this is state 2. This is the path that we have taken, let's say A. This is path B and this is path C. So if x is a state function, it will not depend that how have we covered this distance or this, how we have changed the state 1 to state 2. Either we have taken a process A or path A, either we have taken a path B or we have taken a path C. It is same for all. Okay, if by taking the path A you are reaching to 2, if taking the path B you are also reaching to point 2, and if taking the path C you are also going to reach at 2, which means your initial and final state for all the process are same, not the initial and final, which means final state achieved by these different process is same. So state function will not change. For A, for B and for C it is same throughout, because finally the state is 2, either it is achieved by A, B or C. Okay, so that is the property of this state function. Energy is that kind of state function, you can say, which only depends on the change in state. Okay, now similar way we have path function. So in opposite to the, you can guess now, in opposite to the state function, the state function does not depend on the path. This function will depend on the path. Okay, so those function will depend on the path that we have taken, okay, by the system during the process are known as path function. Example, work and heat. Okay, so the work done is depend on the path, because if you take a longer path the work done will be more. Got it? Either you are lifting that object from a crane to that height edge, or you are lifting that object with your hand, or you are using the stairs to to reach at that height, or you are using an escalator to reach at that height. So it will depend. The work will depend. For escalator it is different. For your foot it is different if you are taking stairs, and for lift it is different. So work depend on the path that you have taken to complete that process, okay, or to reach that final state. Got it? And heat is also, because if more is the work done, more heat will be required. So they are related to each other. Got it? And that relation we will study in first law of thermodynamics. I think we can guess here that if more we have done work, more heat input we have to give. If we want more work to be done by a system, then we need to put more heat into that system. Okay. If we want to rise, if we want to boil the water, 100 kg of water, more heat we have to give. If we have to boil 50 kg of water, less heat we have to give. Okay. So these are interrelated terms, work and heat. Although work is more useful form of energy, heat is not. Got it? This is state 1, this is state 2, and these are the paths that we have taken. Now, if y is the path function, then ya is not equals to yb and is not equals to yc, because now y depend on path. So a is a different path, c is a different path, b is a different path. Got it? I hope you are clear with these two functions, path function and state function. Any kind of doubt you can ask anytime. Now, temperature and zeroth law. So firstly, I will tell you something interesting about the temperature. Let's say we have a system here. This is system A and this is system B. Okay. And they are at different heat is given to them. We are not using the word temperature here. Okay. So let's say the heat given to A is greater than heat given to B. So we know that when we join them, and if this wall that is making contact with these, this is the boundary. If this boundary is conducting, so heat will be transferred. We know that heat will be transferred from more value to less value. Okay. So heat will be transferred here. After some time, if you touch both of them, you will feel the same, that these system A and B are at same thing. Okay. Same cold or same hot. होता है ना ऐसा? If you have a glass of water which is warm, very warm, and here you have a glass of cold water. When you pour this hot water into this cold water, that after some time there will be a hotness and coldness in this system which is different from the previous states. The final liquid that we have, final water that we have, is not hot as the previously hot water and not cold as previously cold water. Okay. Which means if we allow the heat to be transferred from one system to another system, there is a physical quantity which after some times, which is changing at that particular instant, but becomes same after some time. And it is valid for all the process. Okay. All the differences in heat. After some time, if you allow them to flow, allow the heat to be flow or transferred, the final system will acquire the same quantity. Now, what is that quantity? That quantity is the temperature. Okay, so we can say that there is a physical quantity here which is different in case when they are not mixed, but when we mix them, this physical quantity will be same for both, and that physical quantity is termed as the temperature. What it? Although I will tell you that temperature, also we will discuss it on it in the upcoming lecture, but here I will tell you that temperature is nothing but temperature is the measurement of average kinetic energy. Average kinetic energy of a molecule or atom. The temperature is nothing but the measurement of average kinetic energy. Got it? And it is also the degree of hotness and coldness. Now, how hot the system is, how cold the system is, we will decide by measuring the temperature of that system. Okay. Now it is easier to crack for you. So temperature is the measurement of average kinetic energy of the particles in a system. Okay. So you can see here, this is the red hot metal, whatever the metal it is. Okay. But you can clearly see it is hot. And here, this is ice, which is cold. So how you are able to say this? Just by looking at it. But if you are blindly fooled, then how you can say that which quantity is hot or less, hot or cold? By sense it. Okay. By just touching it. Now, the absolute unit is Kelvin. We have used another unit also, like degree Celsius, Fahrenheit, degree Fahrenheit, you can say. Okay. So these are also the unit. Celsius and Fahrenheit. The spelling may not be correct, but the concept is same. Got it? Now, I have told you we have two systems, A and B, and these are at different temperature. Now we can say that temperature is different. Okay, because we understood that this physical quantity is termed as degree of hotness and coldness we measure by temperature. So they are, let's say, at different temperature, and TA has greater temperature than TB. So heat would be transferred from higher temperature to lower temperature. Now, if we join them, then it will depend on the boundary of this system. The heat will be transferred or not. Because let's say if this boundary, if this wall is not conducting, is insulating, it is not allowing heat to flow, then there will be no heat transfer. So that is why we have to study that how many kind of these wall can be. Although it is only of two types, conducting or non-conducting, but we will see it in thermodynamics. First is adiabatic wall. So adiabatic wall is nothing but a wall that prevent the heat interaction. And simply you can also say it the insulating wall. Insulating wall. Okay. Or non-conducting wall. Non-conducting means heat ka conduction. Okay. Non-conducting. Okay. So if any system is enclosed with this wall, like this is the system A, and these walls are adiabatic. So this system will lose no heat to the surrounding. There will be no heat transfer. So we can say that this system is thermodynamically isolated. Okay. Now, the another kind of wall that we have, you can say here, so heat will be reflected from this boundary. ना तो heat अंदर आ सकती है, ना heat बाहर जा सकती है. That type of wall is adiabatic wall or non-conducting wall. Now, what is diathermic wall? Opposite to the adiabatic wall, it is a conducting wall. Just remember simply, it is conducting wall, which allows the heat transfer or the exchange of heat. Okay, that boundary or that wall is termed as diathermic wall. Okay, now very important topic, thermal equilibrium. What is thermal equilibrium? Now, what is equilibrium first of all? In mechanics, we have did that equilibrium is of two type here. When the external force is zero and when the external torque is zero. In when these two conditions are satisfied, we can say that a particular system or object is in equilibrium. Okay, got it? This is called the rotational equilibrium. This is the kinematic equilibrium. Okay, but in thermodynamics, which quantity can flow? If let's say we have two system, or you can say we have two pot of water, which is first it is hot and second one is cold. If we make the contact of them and these walls are diathermic, which can exchange heat through the boundary, so what will happen after some time? After some time, the hot will not be as hot as it would be earlier, and same thing for cold, which means they are exchanging heat somehow, and we know that heat is transferred from higher temperature to lower temperature, and T of hot is greater than T of cold. So heat will be transferred from hot water to cold water. So here, what thing is in motion? Let's say heat. After some time, after some time, the temperature of both the system will become same. Let's say temperature of middle in between. Now the temperature of both the system will remain same. If you put the thermometer in that and measure the temperature, it will be same for both. So we can say that now there is no heat transfer in the system, and that state is termed as the thermal equilibrium. Okay. When there is no net heat transfer in the system, that system is termed as that system is to be said in thermal equilibrium. Got it? How many of you got it? Give me a thumbs up. Or you want me to explain it again? Tell me. Okay. So Virendra has got it. Only Virendra has got it. Student of JNV Baleri. Or what about JNV Ramnagar? JNV Haveri, I think. Yes. Once again. So, yeah, no problem. We have a pot of hot water. We can say it a system also, but by taking water, you can relate it more. So this is hot water, this is cold water. Okay. They are at a different temperature. इतना तो clear है. They are at different temperature. So let's say temperature of this hot water is 100 degrees Celsius. And temperature of cold water is, let's say, 10 degrees Celsius. Now what we have did, we mix the hot water into cold water, or you can do the opposite of that also. Okay. Now we have a pot. Let's say this is a pot, and in between there is a wall. Here we have hot water, and here we have cold water. Now we measure the temperature. It is 100 degrees Celsius, and it is 10 degrees Celsius. We remove this stopper or this wall in between. So they will allow to mix with each other, which means They are transferring heat from higher temperature to lower temperature. So now, if I measure the temperature of this system, it will less than 100 degrees Celsius, less than 100 degrees Celsius, but it is greater than 10 degrees Celsius, which means we can say that hot water has lose some heat and cold water has gained some heat, which means there is an exchange of heat for some time from higher temperature to lower temperature. But after some time, if you measure the temperature, it will be, let's say, 35 degrees Celsius. Just for example, after 1 minute you measure it, it will 35 degrees Celsius, which means now there is no heat transfer taking place. We can say that this time heat transfer has stopped, and that state is termed as the equilibrium, thermal equilibrium for any system. When there is no net heat transfer in the system or by the system, we can say that this system is in equilibrium with the another system. Here we have two systems, na? Let's say A and B. So these two systems, we have made a contact with them. They have transfer heat, but when they are not transferring heat, which means we can say that they have established a equilibrium, and that equilibrium is termed as thermal equilibrium. Now I think you got it. Welcome. Oh, you do not need to thank again and again. It's my duty, okay, to make it very clear to you. So two physical systems are in thermal equilibrium if there is no net flow of thermal energy or heat, you can say. Okay. So this is system A, let's say TA, this is system B at TB. This is the conducting wall, for example. And this is the insulation, which means कि heat जो ये आपस में transfer कर रहे हैं, the transferring heat is taking in between is not transferred to the surrounding also. Okay. So this you have to remember. So when heat transfer stops, thermal equilibrium achieved. Now, if we use adiabatic wall in place of diathermic wall, then is it possible to achieve thermal equilibrium? Tell me. Anyone? Yes or no? Yes or no? No. Virendra is saying no. Obviously. Obviously, because this is the non-conducting wall. If the non-conducting wall is there, adiabatic wall, there will be no heat transfer to system A to system B or system B to system A if the temperature of B is greater than A. And if there is no heat transfer, they will remain at the same, the different temperature. How can they allow heat transfer? And if heat is not transferring, the temperature will not be different for them. Okay. Temperature will not be same after some time. Okay. So they cannot achieve the thermal equilibrium. Thermal equilibrium means we have two systems. So these two systems must have the same temperature. Then we can say that they have achieved the value of thermal equilibrium. Very good. Student of GNV Baleri, you deserve that. Now, this is the zeroth law of thermodynamics. Okay, why it is zero? I will tell you the story behind it. Now, it is just based on the thermal equilibrium. Okay, let me tell you. And you can also derive it or connect it. Let's say we have a system A. Okay, which is in thermal equilibrium with system B. Got it? So we can say that temperature of A is equals to temperature of B, because there will be no net heat transfer to this. Now we have another system C, which is individually in equilibrium with A also and in equilibrium with C also. Okay, so we can say that these three systems are in equilibrium, thermal equilibrium with each other. Okay, this is the zeroth law. Very simple. If we have a system A, system B at different temperatures, and we have a different system C at temperature C, Tc, and this is the diathermic wall, which means they can allow the heat transfer. Now, and this is adiabatic wall, which means that A and B cannot exchange the heat in between. So what is happening after some time? Let me wait for that. I'm just joking. So now we can say that temperature of A is equals to temperature of C, because they have transferred heat initially, because this wall is conducting initially. So temperature of A will become temperature of C equal to, and temperature of B will become temperature of C. When we put the stopper here, which means the adiabatic wall, and we replace this adiabatic wall with diathermic wall, so we can say that this will also exchange the heat. So temperature of A will be equals to temperature of B. We can say that finally that temperature of A, let me change the color, that temperature of A equals to temperature of B, temperature of C. So if a system, if two systems are in thermal equilibrium and there is another system which is in thermal equilibrium with these two individually, so we can say that we must say that these three systems are in thermal equilibrium, and this is the zeroth law of thermodynamics. So if two thermodynamic systems are each in thermal equilibrium with a third one, then they are in thermal equilibrium with each other. Got it? I hope you got it. It's a very simple law. Okay. It is because of the thermal equilibrium. So it allows us to conclude that temperature is a well-defined physical quantity, because on the basis of temperature we can only conclude that they are achieving something, and that something is the thermal equilibrium. And how we are able to measure that? Measure because of the temperature. Okay, just a second. Okay. So in very simple word, if I explain it to you, if there is a system, let's say A, and there is a system B, and they are in thermal equilibrium with another system C. A is in thermal equilibrium with C, B is in thermal equilibrium with C. So we can say that by zeroth law that A and B also will be in thermal equilibrium. Okay, this is the zeroth law of thermodynamics. You can remember this diagram. So you will remember the zeroth law of thermodynamics. Got it? Now I can move the next slide. Yeah. So based on the thermal equilibrium, we conclude the physical quantity temperature. Okay. And that is why we can define the temperature. Temperature is that thermodynamic property whose restricted value define the thermal equilibrium. भाई इसी की तो restricted value से thermal equilibrium achieve हो रहा है, because if A and B are at different temperature, no worries, put them in thermal equilibrium. So the temperature of A will become temperature of B, same temperature. So this is the restricted value now of temperature at achieved at the thermal equilibrium. Okay. So don't worry about these heavy definition. Just try to remember the simple definition of it. Temperature is the degree of hotness and coldness, and it is derived from zeroth law of thermodynamics. Because whenever the system achieve equilibrium, there is a one single quantity which remain constant is temperature. Temperature changing during the heat exchange, but at equilibrium, it is the physical quantity which is same. And that is the story behind this zeroth law. Zeroth law is discovered after first and second law of thermodynamics, and very, very later after this. But in first law and in second law, we already has been using this temperature. And zeroth law tells us about the fundamental of temperature. What is the temperature is? Okay. So that is why we have numbered it at the zeroth. Because this is telling the very fundamental physical quantity, which is temperature. On the basis of that, we are concluding the first law and second law. And third law also. So instead of naming it fourth law, we have named it zeroth law. Okay. So restricted value of the system will lie between 25 to 100 degrees Celsius. Now, the concept of internal energy, heat and work. Now, what is the internal energy? So I will tell you the very simple thing. Internal energy is the total energy of the system. In system. Okay. So this is the, let's say, system in which number of molecules are there. These individual molecules has some kinetic energy. They are moving. Vibrational energy, because they are vibrating at their place also. So all the types of energy, sum of all the types of energy they have is termed as the internal energy. Internal energy of the system. It is the microscopic quantity, because if you move the system whole, you cannot say that in that case also the internal energy change, because we are moving the system will acquire some velocity v. Okay, so it gains some kinetic energy, and then you can say this is the additional kinetic energy, so internal energy will change. No, internal energy is the energy of which is inside the system. Okay, so if these atoms are accelerated, these atoms are moving with much higher velocity than the previous one, then we can say the internal energy has changed. But if the system as whole is moving, then the internal energy will not disturb. Okay. So what is internal energy? Internal energy is the sum of all the types of energy possessed by atoms or system, particles inside the system. Got it? One important definition you can also learn from here. It is the energy defined as random disordered motion of molecules, because molecules always go this types of motion. This is a very random motion. Okay. Got it? So the energy possessed by these randomly moving or disorderly moving molecules is termed as the internal energy of the system. Got it? So internal energy can also be defined as sum of kinetic energy and potential energy of all these small particles. Okay. I have already told you that internal energy is the sum of total energy, sum of all the types of energy that a system possessed. Okay. And it is the microscopic value of the energy. Now, Obviously, if it is an energy, it will be a state function. So it does not depend on the path followed by the process. Got it? So from state A to B or 1 to 2, we have taken whatever the path we have taken, the internal energy is same if the final state is same. Okay. So internal energy is the energy in storage. Internal energy depends upon the temperature. Why? Because I have told you when I'm teaching you the concept of temperature, I have told you that temperature is the average kinetic energy. Okay. So if you rise or decrease the temperature, the kinetic energy will disturb. So we can say that internal energy will disturb. So that is why internal energy depends on the temperature. Energy है तो इसकी यूनिट होगी जूल. Dimension formula you can derive it. Now, what is the change in the internal energy for a process which has final and initial state are exactly similar? Tell me. Tell me the answer. Is it positive, negative, zero, or you can't say because you didn't get it? Tell me. What is the option? Write the correct option in your chat box. Zero, C. Only two. Only two students have answered. What about else? Sorry, what about others? Okay. So you two have got it right because internal energy is a state function. Depends on how you, it does not depend how you have reached that state. What is the final state? That is the concern. And in this question, final and initial state are same. So there will be no change in the internal energy. We have get it back from where we have started. So option C is the correct option. Very good. So it is for both of you. Now heat. Heat. What is heat? Heat is the energy you can see somehow. The energy we provide to the system, the energy we get from the system. So heat is nothing but the energy in transfer. Heat can only observe when it is transferring. Okay. Got it? You have a cylinder in your household. Can you say that it has this heat, this much amount of heat we have? No, you can't say that because heat is a kind of energy which only introduce when it is in transit, when you are transferring it. When you have opened the stove, you are burning the gas, then you will see, then can say that I am transferring the heat to the system, and that much amount of heat you can calculate it. But you never ever heard about it that we have stored that much amount of heat. Never. Have you ever heard about it? That much amount of heat we have stored. No, you can't store heat. Heat is the energy which is introduced when it is in transit. Okay. So heat is the energy in transfer to or from a thermodynamic system. Either we are gaining heat or we are losing heat. Okay. But it is only introduced when energy is in transfer. Either we are gaining it or losing it. Okay. By mechanism other than thermodynamic work or transfer of matter. Okay. Transfer of matter means we have the gas LPG, we burn it, we are transferring the matter, that LPG, and we are burning it. So that is the heat. Heat energy we are getting. So this is the higher temperature, and this line represents the low temperature. So heat is flowing from higher temperature to lower temperature. Okay. So whenever there is a temperature difference or phase change, this is important. Whenever there is a temperature difference or phase change, then heat will flow from higher temperature to lower temperature. And that heat is termed as, when there is a change in temperature, you will sense it. You can sense the change in temperature. That heat is termed as sensible heat. Okay. Sign convention. If you supplied the heat to the system, it is positive. Okay. Heat supplied to the system, always taken positive. Heat rejected by the system, and this is the heat we gained from the system. Na? Okay. So this is considered always negative. Heat transfer is a path function. We have discussed it. Heat and work are the path function. So if we change the path, the amount of heat transfer will change. Yeah, sure. This one, you can take the screenshot and you can say me that I am taking the screenshot. I will pause for this for a second. Okay. Okay. Yeah, do not write it, because in writing you will take more time. Just say it by the reaction. So we have discussed it. Heat is a path function. Change in path, amount of heat transfer will change. Types of heat. Let's say this. Whenever you sense the change in temperature, here the temperature is changing. That heat is termed as sensible heat. And if the temperature is not changing and we are providing the heat, that heat is termed as latent heat. Okay. Because this heat is going to change the phase. Change the phase. Latent means होता है hidden, छिपा हुआ. So when water start boiling na, you measure the temperature, then it is 100 degrees Celsius for a while and you are constantly supplying heat to it. And where the heat is going? Heat is going to convert the water into steam. So that heat is termed as latent heat. Okay. And when you sense it by the temperature change, this heat is termed as sensible heat. So this form of heat is responsible for change in temperature. Latent heat is responsible for change in phase, and it occurs at the constant temperature. Okay. Now, thermodynamic work, very simple definition. So work is nothing but whatever the energy transferred to the system by the surrounding, that is termed as the work done. What is work done? We apply the force on the system. By applying force, what we are saying? If you apply the force for some time, you are doing some work. And if you divide that work by time, that is the power. And that power came from the energy. Energy is the nothing but the capacity of doing work. Okay. So more is the energy you transfer, more the work will be done. Got it? So it is very simple. Thermodynamic work performed is the energy that we transferred to the system. Okay. It can be positive or negative. Either the system is doing work or you are doing work on the system. So here, in the case when it is going down, which means we are pushing the piston down. And if piston is the system, so we are doing the work on this system. But when it is going up, which means the internal, these gases are doing work on the piston. Now the system is doing work. Okay. So also this work is also in transit. You cannot ever, never ever heard about that we have stored that much amount of work. So work done for a closed system is given by W is equals to pressure into change in volume. So it is valid when the system is closed system. Got it? Now sign convention. If the work is done on the system, which means we are compressing the system, that is to be taken negative. And if work is done by the system, which means gas is doing work, it is taken positive. Okay. This is it. Work done is also a path function. So if we change the path, the amount of work transfer will change. Okay. इसकी यूनिट भी क्या होती है? जूल होती है. So it is very important to note that heat and work both are energy in transit. Got it? You cannot store either work or heat. Although you can say that the system has this much amount of internal energy. Okay. So this is the energy. It is noticeable when it is cross the boundary of the system. Okay. Summary में you can say that thermodynamic is the study of heat and temperature and interconversion of heat and other forms of energy. So what is system? System is a region in space in which our entire study is focused. Okay. Properties, what are the properties? It is a characteristic by which we define or specify the system. Change in state from one equilibrium state to another is known as process. Collection of process whose initial and final states are same is known as cycle. And we need at least two process to complete the cycle, to make a cyclic process. Temperature is the measurement of average kinetic energy of the particle within the system. This is the thermal equilibrium. Two systems are said to be in thermal equilibrium if there is no net heat transfer taking place. Okay. And zeroth law, if two thermodynamic systems are in thermal equilibrium with another system, then they are also in the thermal equilibrium with each other. Okay. So this is it from my side for today. If you have any kind of doubt or you want to take a screenshot of any of the slide, I will do it for you now. Otherwise, the lecture is over. Thank you so much for being attentive. Any kind of doubt you have, you can ask. Otherwise, the lecture is being over.